Hello, my name is Dara Wu, and today I'm going to tell you about the game I designed for the past 5 weeks called Smart Shopping with the Wu family. So this is what the game looks like when you first open it. There's a message that reads the background story behind this game. Hello, today you are shopping with the Wu family. However, you know that the Wus are not very smart shoppers because they always pick the most expensive item. Because they are your friends, you decide to help them pick the cheapest item based off of the sales price. And here's just a funny picture of my uncle shopping, who's very sad because he's holding my cousin's clothes. So I'm just going to start the game right now. And as you can see, there are 4 levels. Each level increases in difficulty because with each level, the price of the item gets bigger. So for example, in the last level, the prices are close to $1 million, whereas in this first level, the item prices are closer to like $10. In each level, there are 3 items. Here there are 3 Odwalla bottles because those smoothies are delicious. And it is the user's mission to determine the cheapest option based off of its sales price. When the user finishes the question, they receive some feedback on whether they got the question right or wrong. So I'm just going to select an answer right here and click next. So yay, I got the answer right. So I'm going to go on to the next level. And oh no, I got the wrong answer. When the user gets the wrong answer, meaning they did not pick the item with the cheapest value, lowest value, they're given a tip on how to improve themselves for the next time. So as you can see, I used a lot of image files in this program. I used images for the items you're buying and a different image for each level's incorrect or correct slides. Because I designed this game to help middle schoolers learn not only how to calculate sales price, but also how to multiply percentages, I used a paper diagram and tested this game idea with my younger 6th grade sister. Here we are. While she did say that the questions were actually directly correlated to what she was learning in math, she thought that the game was a little boring. This is why I added the aspect of shopping with my family in all the image files. We both felt that it made the game more interactive, engaging, and fun. The image files provide the user with direct feedback using colors and humor, rather than just a few words, which may be discouraging. Alright, so next I'm going to tell you how I use the image files. The action performed method, which is inherited from the action listener class, allows me, or rather the game, to listen or wait for when the user clicks one of the radio buttons, selecting which item they think is the cheapest. So here's just a little tidbit of my code. This is the code for my easy question, which is just the very first question with the Odwalla bottles. So after clicking one of the buttons, the program goes to the action performed method. When the user selects the right radio button, or the item that is the cheapest, the Boolean, easy question correct, becomes true. If the Boolean becomes true, the user's score then increases by 1, and the program or the game shows the correct slide, which is just to help the user receive some feedback. But if the user gets the answer wrong, then the easy question, which is preset to be false, just remains false, and the game shows the incorrect panel. So at the beginning of the design process, I wanted the question to keep repeating if the user gets the question wrong. But it was actually my Java teacher, Mrs. Fraser, that suggested that I provide the user feedback using correct and incorrect slides. So in the end, I'm really happy I listened to her because I was able to easily incorporate a scoring system, which provides the user with even more feedback. Okay, so on a different note, here's how I generate the problems. I first generate a random number from 1 to 10 using math.random for the price of the item, as you can see right here, and another random number from 1 to 100 for the percent off. Because math.random actually returns a double or a decimal, I casted the return value right here as an int right here, which rounds the double to the lowest integer number. When I first designed the game, I was a little worried about how I was going to have the levels increase in difficulty. My math teacher, or mentor, Mr. Jennings, actually suggested that I used bigger numbers as the levels increased. So this is why I used math.random, because it is easy to generate a really big random number. Well, there we have it, folks. Smart shopping with the Wu family. My name is Dara Wu, and thank you so much for listening.